Hello everyone. Good morning, good afternoon, good evening, depending on where you're joining from. Welcome to the sixth edition of Data Platform Summit, and we have gone virtual this year, so it's very wonderful to be part of Data Platform Summit. So today my session is on deploying Azure SQL infrastructure using Terraform. A quick intro about myself. I'm Manohar Punna. For those who don't know me, there is a lot of information on this slide, so all of this is uploaded as part of the conference material, so you can go through these details later on. The most important thing on this slide is my Twitter handle at the bottom of the screen. So that's the best way to reach out to me in case if you have any questions regarding this session or anything related to Azure Data Platform. My Twitter handle is ManuSQLGeek. And I also serve as a vice president of Data Platform Geeks. So Data Platform Summit, I'm part of the organizing team and help organize sessions and schedule the sessions for this conference. So today's agenda is on creating Azure infrastructure. So resources related to SQL on Azure, mainly using Terraform. So Terraform is a configuration language that we use to deploy infrastructure and maintain infrastructure as code. So we'll be quickly going through the DevOps principles, not going into very much detail on this one. We'll be looking what's the importance of maintaining infrastructure as code and look at the basic concepts of Terraform. How do you use it? How does it compare with ARM templates? And we will see that in the demos as well. So quickly going through the DevOps principles. It's the basic principles of DevOps is abbreviated as CAMS. So the culture, automation, measurement, and sharing. All of these are very important for implementing DevOps in an organization. But the technology aspect of it, which is how do you maintain your code, how do you push it across different environments, and how do you version control it, all of that falls under the automation umbrella. And under automation, we have got we want to make sure that we automate everything. Uh, Previously, in on-prem environments, generally you would have applications or databases or any software which will be maintained as code, and you version control it and you make sure that it is deployed across environments and is consistent across all your environments. Uh, with the new world where we have most of the infrastructure maintained by cloud providers like Amazon or Microsoft or Google or Alibaba Cloud, you name it, but most of them actually have hardware that they maintain, but abstract a layer on top of it, which will help you create your own infrastructure on the fly, right? So to make sure that you can run the code to create that infrastructure and make sure that it happens on the click of a button and it is consistent across different environments. You want to make sure that you are not deploying anything which is unintended. You want to have a control of what's being deployed. All of that is possible when you can deploy that infrastructure by using code. So we want to make sure that we automate everything, including infrastructure deployment when it comes to cloud platforms. You want to make sure that you version control your code, so you can roll back to a specific version which you think is going to work for sure. If you're making some changes, you want to make sure that you track those changes over a period of time. And when it comes to DevOps, the whole heart of it is you can actually do continuous integration and continuous deployment. So that's where you can include your test-driven development and make sure that you can once you test everything in your development, it's automatically integrated into your code and then deployed to further environments like your test and prod on specific approvals, of course, but making sure that that is included in the process. So all of that is possible with DevOps, and now it's available for infrastructure as well. So when it comes to infrastructure, you want to make sure that you maintain your code as you maintain your infrastructure as code. And there are many tools available that will help you achieve this. My preferable tool that I use most commonly for maintaining my infrastructure as code is Terraform. The reason I use Terraform is there are a few characteristics of Terraform, which is different from other development platforms for building your infrastructure. So with Terraform, you can build, you can change your infrastructure, like you can deploy changes, and you can version control your infrastructure. It is similar to other, infrastructure as code platforms like your ARM templates or your CloudFormation. But there are specific features which is, very relevant to Terraform or very useful when you're using Terraform. One is its high-level configuration language, right? So like ARM templates where you have to write everything in JSON format, it's very hard to actually read through it or make or troubleshoot your code when something fails. With the syntax that we use for Terraform, it's very easy to read and understand what's going on when you are trying to create resources or trying to use modules in your code. It also provides you an execution plan, which is new to infrastructure environment, right? So you actually know what is being deployed. It maintains the information about the resources, and then it will give you an execution plan of what is going to be deployed when you run your code. So whether it's you're applying the code directly or whether you're doing a planning phase, it will still give you an execution plan. So that's always very important to notice, and it helps you to understand what changes you are making. Terraform by default maintains a resource graph, so it knows what is the dependency between different resources that you are deploying with your code. There are you can work with multiple cloud providers when you're using Terraform. So Terraform is cloud agnostic, so you can deploy it to AWS, you can deploy it to Azure, you can deploy it to Google Cloud, and you can write your own providers to work with your own infrastructure, physical infrastructure as well. So all of that is possible with Terraform, and it ensures that when you run a code, the the consistency is maintained between your code and the resources are created as defined in your code. So that creation and consistency is maintained when you're using Terraform code, and it is based on a plugin based model, so you can actually have multiple plugins into your Terraform code. Like you can use a single repository to deploy both your Azure and AWS infrastructure at the same time. So that's possible with Terraform, and you can deploy incremental changes. It doesn't have to be in one go. You can actually work in an agile fashion with your Terraform, so that you deploy your changes incrementally, one resource after another, or keep adding features to your resources that you create on your cloud platform. It lets you preview your changes, so this is part of your execution plan, and definitely it's scalable because you can extend. This is highly extensive, so you can actually extend your code and keep on adding resources, and by reusing modules you can keep your code dry, and it's easily scalable when you're working with Terraform code. So I'll quickly go through the basic concepts of Terraform. Like any other programming language, it has got variables for providing inputs or defining some fixed values. It will give you some outputs that you can use, that can be spit out from your modules and can be reused in other modules as inputs. Um, it gives you different providers that you can work with, modules, and it will show you an execution plan, and when you've got a plan, you can apply it or directly run and apply with an implicit plan that comes up when you run the apply command. It has got a state file, which means that it maintains the state of your resources in a file, so it knows the state and compares it whenever it tries to deploy any changes to your resources. And you can destroy all your resources by a simple command, by providing the variables that is required from your Terraform code, from the same code base. So variables, as I've said, like they are inputs to your code and they are type constrained. So that means like you can define the type of the input, or the string or number or boolean. You can also build constructs out of your types, like you can build a list of strings or set or a map or an object or a tuple. You can also provide that input as a JSON or in any format, like in JSON format, in a command line argument when you're running the Terraform apply command, or you can provide it within your code itself as an HCL file. As I've said, like with Terraform, you can work with multiple providers. So providers are nothing but the definition of resource types. So for Azure resources, you will have an Azure RM provider. So all the resource that you can deploy with Azure is defined in that provider. So you need to use or call that provider to be able to deploy resources to a specific cloud platform. The configuration of the provider, you need to provide that as well. So there are few specific configuration parameters that you need to provide with your resource with the resource provider. Like for Azure RM, you may need to provide your version of the Azure RM provider. You must initialize your code, that way it actually downloads the plugin from the Terraform HashiCorp site, and then you can provide multiple instances. So it doesn't mean that you have to stick to one specific version. You can also mention like a duplicate of Azure RM provider, say one is 2.3 version, one is 2.2 version, right? So you can use multiple version in your same code base. Modules is more like grouping a set of resources together, which will give you a single set of functionality. Say it's similar to how you do your functions in your any programming language, which you can reuse across different programs. So they are container for multiple resources. It takes like the input parameters and returns the output from the module. And definitely you need to have at least one root module. We will see this when we are doing the demos. And modules also lets you keep your code dry. Dry means like in programming language, it's do not repeat yourself. So it lets you do not repeat your code at multiple places. You can actually define it as a module and use it in your code or call it in your code. Plan Terraform provides a plan by running a Terraform plan command and passing in the variables. It will give you the execution plan of your code. So as I've said, like it will show you what incremental changes are you making, or if you're running it for the first time, how many resources are you creating. So it will give you that plan as part of your Terraform plan. So it will not make any changes to the infrastructure, and you can save the output of this plan and use it with your apply command. By default, when you apply a Terraform code, it will apply the changes based on a plan. If you haven't saved a plan, if you haven't run the plan before and saved it, it will implicitly run the Terraform plan and then use that plan to execute and create those resources, right? And when it comes to the resources that you are creating with Terraform, the state of those resources is maintained in a state file. So Terraform uses the state file to know the state of the resources, and say if you're creating a resource with specific set of configuration, and all of that is saved in the state file. If someone goes to Azure portal and makes a change to that resource manually, next time when you run your Terraform apply command with the same code base, it will revert all those changes that has been done manually. So it maintains a state file and makes sure that your infrastructure is consistent with your state file. So that's the purpose of state file. It's very important because you have a specific code base, you have version controlled it, and you want to make sure that your infrastructure is consistent with your code base. So that's where state file plays very important role. And it'll also help in mapping the dependencies between resources, and it knows when you try to destroy or remove a resource, it will know that what other resources are dependent on a specific resource. And I've mentioned like when you run Terraform plan, it will show you an execution plan. So that plan and the execution plan that is shown when you're running the apply command, they both use this state file to actually show you what is the incremental changes that is going to be applied. So that's how the state file is being used with Terraform. Destroy is pretty much straightforward. When you run the destroy command, all your resources are destroyed. So they are deleted from your platform. The good thing is like you can actually plan the destroy as well, similar to your apply command. You can see what resources will be destroyed. So accidentally you can't just go ahead and delete all your resources. What you can do is actually run a plan command and then destroy the resources that you are actually supposed to destroy. Right, so that's pretty much what I have wanted to cover in the slides, but we'll look at the demos and understand more about like see Terraform in action. All the demos that I'm showing today are available on the GitHub, and I have put the link of that resources in the slide deck. So I'll be first covering a single module where it's like the root module and create all the resources in one single module. I'll show what the limitations are and how the actual Terraform works there. And then I'll step into how we can do the same thing instead of a monolithic single file, how I can split that into multiple modules and what's the benefit of doing that. And then we'll look at an example of using complex variables where we'll loop through a set of a list variable type and create multiple resources of by using a same module. Let's start with the first demo, which is a single Terraform file which will deploy all my resources. Even though I say single file, I'll still split the variables into a separate file so that it's easier for me to maintain the variables. And I'll use the main file, which has got all my code to create the resources in Terraform. And then I'll use separate TFRs files where it's more like an input to my Terraform command when I'm running to create my resources. So it's actually the values of the variables that I want to pass. So it's a list of variables that I'm passing as an input. So in Terraform, any file that should start with main.tf. So .tf is an extension, and it, as I've said in the slides earlier, it uses a HCL syntax, so high-level configuration language. So when you're running Terraform, you need to specify few blocks, which is always required. It's like the provider block. So in this case, I'm mentioning that I'm going to use Azure RM Provider, and the required version is the latest one, which is kind of released on November 27th. So 2.3.8 is the Azure RM version that I'm using. You can always find this information on the Terraform site. And then in the Terraform block, I say, there's one provider required, which is Azure RM. So when I was talking about provider blocks, I mentioned that you need to provide the configuration of the resource provider. So this is kind of the configuration that is required for Azure RM. There are additional configuration that you can still specify, but in this case, that is good enough for my code. And once you have got that resource provider mentioned here, the next step is how do you create the resource? So creating a resource is pretty straightforward. What you do is actually say use the resource block and say which type of resource you're going to create. Like in this case, it's a resource group that I'm creating. And I give it a reference name in my code. So this is more like a name for that particular resource, which I can use to refer it back if I want to reuse it in some other resource. I'll show you where I'm using it just below that code. If I want to create multiple resource group, I need to give different names every time I create a new resource group. So in this case, if I want to create another resource group, all I would say is create that and give it an example 1 or example 2, right? So that's how I need to name my resources when I'm creating within Terraform code. So this is more for Terraform to understand like what resources you are creating. And for this, I need to provide definitely some parameters that are required. Like for creating a resource group, I need to specify the name and the location where that resource group will be created. The next one is I'm creating a SQL Server resource. Right. In the SQL Server resource, I need to specify the name of the SQL Server, which is the first variable here. The second parameter that I need to provide is in which resource group do I create this SQL Server resource. And if you observe here, I'm actually referencing the resource that I've created previously. The way I do it is specify what type of resource it is, Azure RM resource group, and the name of the resource. So for example, if I create two resource group, I can refer to a specific one by providing the name of that resource. And then the actual value that you are passing, like the name. So this can be the input variables that you pass, as well as some of the properties that it will add when the resource is created. Like, and I can refer to a resource ID as well. So here for creating SQL Server, I provide the name, resource group, the location. I'm using the variable instead of depending on this particular resource group location. Or I can actually use a similar format. I can say Azure RM resource group dot example dot location. So that could be also be my reference to the other resource that I'm creating here. What this will do by naming your, by passing the variable, the parameter as referring to other resource, it will create an implicit dependency. So your SQL server will not be created until your actual resource group is created by just specifying, referencing the other resource in here. So it creates an implicit dependency. You can also specify explicit dependency. So you can say instead of using this reference name, I can just pass the variable, but it will not know whether that resource exists or not. To create that explicit dependency, when you pass the variable name, you can just add a depends on block. So you can just say depends on and then provide the resources on which it depends on. So you can say this particular one dot example, and it will not create this MS SQL resource till that previous resource is being created, right? So that it works something like that. All right, so let me revert all those changes back because I've already created the implicit dependency, and then I pass in the other values like the location, the version of the SQL Server. This is hard coded, so I want to make sure that I always create the SQL Server at 12.0. I pass in the login and password. In this particular demo, I'm passing the password as a plain text, but what generally we would do is use a random password generator with Terraform, and then save that to Key Vault and then query that Key Vault and then use it. For this simple demo, I'm just putting it as a plain text, but it's not recommended to put all your password in plain text in your source code. Never do that. A strict no-no with security. And once I create my SQL Server, I will create a storage account where I'll be saving my audit logs. So again, Azure RM storage account is the resource that I'm creating. Give it a same name, that doesn't matter as long as the resource is different. You can't give the same reference name to the same type of resource in your code. If it is a different resource, then you can give the name. So it's the combination of the resource type and the reference name should always be unique. Here I'm again implicitly creating dependency between the resource group and storage account. So it will not create storage account until the resource group is created. And here I'm creating a SQL database after that. So once I create my SQL server and storage account, I create my SQL database. And here I specify that get the resource ID of my SQL server by referencing the MS SQL server example.id. So .id is not an input variable. This is something that is created when the resource is created. So it's the resource ID, like the GUID that Azure creates when a resource is created, like the resource ID. So that is coming out of this resource when this resource is created. So it is not known till the resource is created. So I will reference it by saying .id. So it will wait till that resource is created and gets that ID and uses it in this module, in this resource. And here I'm specifying the extended auditing policy. And here also, if you observe, I'm referencing the storage account and saying that you get the blob endpoint and access key. And when I'm creating the storage account, I wouldn't know that, right? You will not have an endpoint and access key till the storage account is created. So implicitly I'm creating the dependency as well as I'm telling that fetch those values from this resource once the resource is created. So implicitly it will not try to create this database till the storage account and the SQL server is created. That's it. In 54 lines, almost 54 lines of code, I'm actually creating a resource group, creating a SQL server, a storage account, and then creating a SQL server database on that SQL server created previously, and then adding an auditing policy. All of that within 50 lines of code. So the learning curve with Terraform is very small. So it's very easy to pick up on using Terraform to create your resources. Let me quickly show you how does that look like when I use instead of Terraform, if I use ARM templates. The same set of resources, I create a resource group, a SQL server, a storage account, and then the auditing policy for my SQL database to write to storage account. And in ARM template, you can see it's definitely not readable. It's not very easy to browse through your code and understand what's happening here. And if you scroll down and see how many lines it took, almost 700 lines. Yeah, sure, definitely you're not going to sit and write all of this code, but it's very hard to troubleshoot when you have the JSON ARM templates to work with your resources or troubleshoot your code for that matter. Right. So let's go back to this one. And how do you run it, right? So if you observe, there are a few things that I have mentioned but didn't cover. One of them is the variables. So I'm referencing these variables, right? So I'm passing these variables to this particular resource. Where do I define the variables? I mentioned during the presentation that you can define the variable and specify a type constraint for your variable. So I create a variables.tf file, and in here I actually define the variables. I say resource group name, and it is of type string. It is of type string. I can define some other variable types, but like a map. So a tags is nothing but a map variable, right? So in here, by default, it's nothing, but I mentioned that here I'm defining the variables, but I need to pass the values of the variables as well. I can specify default values and run with it, like any other programming language, or I can pass the variables during runtime. So I have created two other files for my dev, one for my dev environment, one for my prod environment. So in my dev.tfvars file, I'm just passing those values. Like for my resource group, that's the resource group name, that's the location. And in here at the bottom, you can see at the tags, I have mentioned a map type variable, which is like a key value pair, environment dev, and the purpose is tf dev presentation. And ignore the password in here. It's in plain text, but do not do that. Always use like key vault or any other password store to make sure that you are securing your environment. So let's go ahead and see how you can run this. I'll make sure that I log in to my Terraform, log into my Azure account. So easy login. So this will take a couple of minutes to make sure that I'm logged in. All right, that's my account. I'm just logging in on the other screen. Yep, that has finished the login, and it will now show me all the subscriptions that I've got. And I see that I've got two subscriptions, but I want to make sure that I actually deploy this to a specific subscription, not just pick it randomly. So I'll set my account to use a specific subscription and make sure that that is the subscription that I am connected to. All right. So now I ensure that all the resources will be deployed to a specific subscription, right? That's all Azure commands, Azure CLI commands, nothing Terraform so far. So to first make sure that it works, you need to initialize your Terraform module. So I'll run a Terraform init command. It will help if I make sure that I type in the command correctly. And then I need to go into the folder where I've got the main.tf file. Now it has initialized. And what happens during initialization is actually it goes ahead and sees what you have got in the provider block. It sees there's an Azure RM 2.38 version, and it will create a temporary folder and downloads that plugin into your temporary folder. So here you can see like it has downloaded Azure RMV 2.38.exe file, right? So that's the file that it has downloaded. So that's the provider that we are going to use. Now once it has downloaded that, now I can run my Terraform plan. So I'll go ahead and run a Terraform plan, and here I specify to use the variables from dev.tfvars. So this is where I have defined all my Terraform variables for this particular environment. So I'll use that tfvars file. When you're running this from your DevOps pipelines, generally this would be a variable group that you can use, where you can define all the variables for your environments. There also you can still save your password as a secure string, but key vault is the best way of doing it. So what this is doing at this point is actually checking my Azure environment. Because there is no state file, it will create a temporary state file and checks that whether you have got any resources in your Azure environment which matches these descriptions. If it doesn't see anything, what it will say is it will go ahead and create all these resources. So plus sign is for create. And then here you can see it will create a SQL database resource. The name and everything is coming from my variables. Everything else is what it will know after it's created, right? And then there's a SQL Server resource. It is creating a SQL Server resource. And if you scroll down, there's also a There should also be a resource group. Yep, there it is. It's creating a resource group resource, and it's also going to create a storage account resource. So it will create all these 4 resources. And at the summary at the bottom, it says I'm going to add 4 resources. I'm not changing anything or I'm not destroying anything. And this is the plan. This is the execution plan that I was talking about. So you can see exactly what's going to be deployed before you deploy your code to create the infrastructure. So let's go ahead and actually run the apply command. As I've said, if I have saved this plan, I can use this plan to run my apply command. But even if I don't save this plan, I'll just run apply and it will implicitly create a plan and then shows me the plan and asks for a confirmation whether to apply or not. You can bypass it by specifying to skip the prompt, but in this case, let's see what it comes up with. See, it says the same thing. It shows the exact execution plan that it has shown me when I was running the Terraform plan command. And at the bottom, it says it's going to add 4 resources. Yes, that's what I wanted to do. And it will ask whether you want to perform these actions. So you can review your execution plan and say, yes, go ahead and create those resources. And when I do this, it will go ahead and actually create those resources in my Azure portal. There is a slight delay when this runs, like this is mostly using the backend, like it uses Azure RM provider to create the resources. And sometimes there is a delay between when this says it is completed and when the portal executes. It's not a problem with the code. It's mostly the delay between Azure portal refreshing and showing you what is happening behind the scenes, what resources are created, what's been allocated, and all of that happens behind the scenes. So let's go ahead and see the portal here. I've got like six resource groups here. I'll refresh this and I should see the new resource group that is created with that Terraform code. So it is tfdev.rg. That was my resource group name. You can go back here and see that, yes, that's my resource group name. And in here it says it is creating storage account and SQL Server. So if you observe here, when it is running, it first created resource group. Once the resource group creation is completed, that's when it started creating both storage account and SQL Server. These two don't have dependency between each other, but they both have dependency on resource group. So the order of execution would be like create the resource group first. Once it's finished, then create SQL Server and storage account. And once both of them are created, like my SQL Server is still being created, once we see that the storage account and SQL Server is created, then it will go ahead and attempt to create my SQL database. So let's go back to the portal and we should see that storage account will be coming up here. Yes, so storage account and SQL Server are created now. And in here, let's see what's going on. Yep, SQL Server is still being created. It takes about generally a minute or two to create the SQL Server resource. So it's the allocation in Azure. But it's generally the execution time that you will see even when you like do the click next in your portal and then create the resource. All this while when it is running, it is also actually saving all the state of these resources while they are being created into a state file that I've mentioned during the presentation, right? So the state file is again saved locally here. If I specify a remote location, like I can save it to a central location on my Azure Data Lake or some other blob storage, but in this case it's saving locally. And I can't open this right now because it is executing. So you can observe here that a SQL Server creation is completed and then it starts creating my database. So once this is created, I can show you the state file and show you what it actually saves. And Terraform uses this state file to maintain the state of your resources as I've mentioned in the presentation, right? So let's click on that tf state file now. All the resources are created. It says 4 of them are added. That's good. That's what it was supposed to do. And if you observe here, this is again a JSON file and it saves the configuration of all the resources that are being created. So you can see here it is actually saving that I've created a database and that's the configuration, the collation, and every other details that's coming out of my resource creation when it is created with Terraform. It also stores the storage endpoint, the auditing policy that I've mentioned earlier, and then it saves the retention period and all of that defaults that are created with my database because I never specified all those values. If you scroll down, I can see I've got the SQL Server information here as well, and the resource group and my storage account. And make sure that this file is secured. You don't save it locally anywhere because it has got some sensitive information as well. So it's always recommended that you save the state file on a blob storage and give access to only like this, the super users like the cloud admins and the Terraform DevOps pipelines which runs this code, so that only those can access this file. The reason I say that is if you observe here, it is actually saving the primary access key of my storage account, which is like the God mode of storage account, and it's saved in plain text. There are these kind of things which you need to make sure that security wise they are all saved correctly. So make sure that this tf state file doesn't go into the wrong hands or placed in a wrong location. All right, now we have seen the state file. How does Terraform use the state file? So let's go ahead and make a small change in here. In my dev.tf files, what I'm going to do is there are two types of changes. One is like a breaking change, one is more like a incremental change. So for example, for my SQL database, if I change the name of the database, it's a breaking change. It will drop and recreate the database. If I just change the tier, which is more like configurable, scale up, scale down. So I'm changing my tier from basic to S0. So let's go ahead and do two things. One is change the database name, which is a breaking change, and change the SKU name, which is the incremental change. Let's go ahead and run the apply now. So after saving that change, I'll save that file and then go ahead and run the apply command again. Now running this apply command, you can observe that it is actually refreshing the state of the based on the state file. It will check the resources on Azure that were created and then compares them with the state file that I've got and the changes that I'm going to apply. So it should see two changes. And if you observe here, it says it will actually going to destroy and recreate. The reason being, I'm trying to make a change of the database name, which is a breaking change. And it explains that it actually forces a replacement. That's why it's going to destroy and recreate. So let's go ahead and actually cancel this run. So, and what I'll do is undo the database name change. So this is going to make an incremental change only. So let's go ahead and apply this one. Now this is doing the same thing again. It is refreshing the state based on the state file, but it should not see a breaking change now, but it should actually see an incremental change. And that will be reflected in the plan that my apply command will generate, like the plan is generated implicitly. And if you scroll up, you'll see that there is an update in place. That means it's not going to destroy anything. It will just append the changes. So these are incremental changes. And you see the change that is actually causing that append is the SKU name. So it's going to change the SKU from basic to S0, right? So that's the change that we want to approve. So I'll not be running that change now because I know that's going to work. So what I'll do is actually go ahead and show you how the destroy works. So I'll use the same command but just change apply to destroy. I can plan this, but implicitly similar to apply command, destroy also shows you the plan that it will run. Now it will show me what will be destroyed. So if I scroll up and see that it's going to destroy all the things that are marked with red negative sign. So it says the SQL database will be destroyed. If I keep scrolling down, I'll see my SQL server will be destroyed, and the resource group will be destroyed, and the storage account will be destroyed. So all the 4 resources will be destroyed as part of this. And it also shows up in my summary at the bottom. As per my plan, I'm going to destroy all the 4 resources. So let's go ahead and approve that destroy. So it will go ahead and destroy all the resources on my Azure. Let's visit this back while I jump into my second demo. While this is running, let's see what we are going to do with second demo. So for the first demo, what we have done is seen that all the resources are created in one single file. What if I want to split this up? I don't want to run all the resources, create all the resources in the one single file. It is easy when you're creating just like 4 or 5 resources. But assume if you're creating like, 20, 30, 40 resources in your infrastructure. And that is quite common when you're creating like end-to-end pipelines in Azure for your big data, data pipelines. So in those scenarios, you actually want to make sure that you split them up into modules and create them based on different functionality. So let's go ahead and look at the other folder called modules in here. What I have done here is split that resources in one single monolithic file into multiple resources, like multiple modules. So SQL DB, SQL DBs, SQL Server storage account. So in my main file on the root module, I am creating, I'm specifying the provider block, Terraform block, which is like required for every root module. And then I'm creating my resource group in the root module here. And from there on, uh, for creating storage account, I'm actually calling a module and referencing the storage account module here. On the left side, you can observe that's the storage account module. And for SQL Server, I'm calling the SQL, I'm referring to the folder where I've got the SQL Server module. Similarly, for the SQL DB, I'm referring to the SQL DB module. So let's see how that module works. Let's first start with storage account. So in here, I've got the main and variable file. So in the main file, I am using the same provider Terraform blocks. I'm querying the resource group object type and say, get me some information about this specific resource group and use that information when I'm creating my storage account. Because this module doesn't have any idea about what resource group that storage account needs to be deployed. So I'm getting that information by using a data block. So data block in Terraform lets you actually query a resource and get the information that you need about that resource. So I'm using data block to get information about my resource group and using that to create my in my storage account resource. So that is the only resource that I'm going to create here. And I define all the variables that is required for this particular module, like my resource group name as an input, the SQL Server name, and my tags. Let's go ahead and see what's required for my SQL Server. So in here, I'm doing the same thing. I'm actually querying the resource group and passing that information to my SQL Server resource. So this is similar to what we have seen in the monolithic module, the first demo. And in SQL Server case, I'm also doing one more thing. I'm actually specifying the outputs. So I want to make sure that I give some information out of this module so that can be used in my other module. So there are two ways of querying a resource. One is use the data block. The other one is refer a module output. So in my module output here, I'm passing out the SQL Server name and the resource ID of my SQL Server. Let's see how I'm going to use it in my root module here in my main file. I create storage account. I create SQL Server resource by calling that module. And then when I'm trying to call my SQL DB, I refer to my SQL Server module. This one, module.SQL Server name. So I pass that information that is coming from my SQL Server module, right? So that way I can pass this information from one module to another module. And in my SQL DB module, I'm going to use that information and get that information from my data blocks or directly use the information that is coming from the module and use that as my variable in my SQL Server database resource, right? And there's no difference in this resource configuration. It's similar to what we did in the other example, the first example, but just splitting this up into multiple modules. What's the benefit? Why do you want to do that, right? Why do you want to split it into modules? In the main module, let's assume that here I'm creating one SQL database, right? In a single file, if you're trying to create multiple databases in your SQL Server, you will be repeating that resource block multiple times. So instead of doing that, you can call this module in a loop, right? So you can call this module by using a list variable where you can add multiple values in a list format and then loop and call this module multiple times in a loop rather than copy and paste your code multiple times or copying and pasting your module or resource multiple times. You can use the loops, right? And also this makes your logic a lot more simpler. Like you can do a lot of, here in this case I'm creating one resource in a module, but you can create one single module for creating SQL Server and the database in one go. So all 2 or 3 resources will be combined into one single module, and you just call that module by passing in the variables that is required for that particular module. All right, just switching back to the terminal window, I can see that all the 4 resources are destroyed from my first demo. Um, that is not required. It's not going to be build much. I can leave it on for this particular demos, but I've decided to destroy it, and I've demonstrated the destroy command. So let's go into the modules, browse to the modules folder, and in here I'll do a Terraform init again. So this will initialize this particular folder again. So it has downloaded all the providers. If it's already done, it will not try to download again. It just initializes it. Now I will go ahead and run the apply command. Here I've got 2 other TF-vars files, like the test and the prod. Let's go ahead and use the test TF-vars. So, I mean, this is no different from my first demo. So it will go ahead and create the resources. So at this point, I'll switch gears and actually move into my third demo. So I'm actually combining my second and third demo and show you how the loops work, how you can reuse your code by just specifying one single variable of a list type and loop through and create multiple resources by just depending on the variable. So in here, I have got another module called SQL DBs, right? Just a plural form of it. In here, what I'm doing is doing the similar thing what I've done with the SQL DB module. I'm getting the information about my SQL Server, about my storage account, because that's the dependent objects that I need before I create my database. And in my database, if you observe here, I'm using a count. By using count and setting that count to a specific value, it will repeat and create this resource this many number of times, right? So it will build an array and go through that array and create the resources based on the length of that count. So say if I specify the count as 3, then it will repeat this, create this resource, try to create this resource 3 times. And you also need to pass the variables based on the loop, right? So how do you refer that? So I have defined a variable of type list, and in the list I'm passing 2 values. So list of object, the DB name and the SKU name. So each database will have the name separate and the SKU name, like whether it's basic, whether it's standard, or that value. So I will loop through that, and for each item in that list, I will create a database with that specific name, and the way I refer to that index is like count.index, and access the name and also access the SKU name with the same index. So that way I'm going to loop and create 3 resources by using count, right? And everything else is same. All of the other details are similar, like same across all the 3 databases. Only the name and the SKU name are the ones which I want to dynamically change based on the length. And if you see my test.tfvars file, I have got the SQL DB's value, and here I'm going to create 3 databases dynamically. I can increase this length. I can keep on adding like 10 or 20 different databases in one single go in this particular loop, in this particular list. So here, if you observe, I'm creating 2 databases with basic and then 1 database with standard S0 tier, right? So that's very dynamic, right? You can make this more like, for your elastic pools, you can actually specify creating multiple databases into your elastic pool, and this can be dynamic. So you need only maybe 5 databases in your test environment, but when it goes to production, you may need 10 databases. So you can specify different values and different variables in your different TFVars files. So let's go ahead and see how this will work with test.tfvars. So in test, I'm creating 3 databases, remember, and it's going to create those 3 databases in 4 actually, because one of them will be created with my SQL DB module as well. So if you observe here, I'm calling the SQL DB module here, and then the SQL DBs module, which is a plural form, which will create 3 more databases. So let's see how that will come up in my Terraform plan. I'm not running the plan explicitly, but implicitly when I run apply, it will actually generate a plan as well. So let's see how that will look like. Alright, now it has generated the plan, and at the summary at the bottom, you can see that it's going to create 7 resources. And if you remember, I was creating 4 before, like the resource group, the storage account, SQL Server, and SQL DB. There are 3 more SQL databases that I have added, so that comes to 7. And we can see how the resources are created. So this is the storage, what all resources will be created as part of the plan. So the storage account, keep scrolling up. I am going to create a SQL Server, and I'm going to create 3 databases. And if you observe, it's an array with the index starting at 0. So basically the SQL database at index 2, which is my tfdb3, and that's coming from my test.tfvars file. So if you observe here, my third database name was tfdb3. So that's my third database. If you keep scrolling up, then I'll see my index 1 at index 1, which is tfdb2, and then another one which will be tfdb1, which is at the 0 index, right? So those are the 3 databases that will be created as part of this module, but they are created as part of a loop rather than calling the module multiple times. And above that, there will be one SQL DB, which is part of my SQL database, like the SQL DB module. That's the SQL DB module. All right. So now I've seen all the resources. That is what I wanted to do. So I'll just run. I'll just confirm. Let's go ahead and create these resources. It will take few minutes to create these resources. So I'll wait for it to run. Alright, it started by creating the resource group. So that was the first resource it will create. And once the resource group was created, it fetched that information, and then because I use the data blocks, it actually gets that information and starts creating the storage account and the SQL Server. Once those two resources are created, and then it will go ahead and start creating the SQL DB and the SQL DBs at the same time. So we can observe here that it started creating SQL database and all 3 SQL databases from the SQL DBs module, the plural. And once all of those databases are created, it says 7 resources are added, and we can verify this in our portal. So let's go back to my resource groups and then refresh it and see that there's a new tf test rg. And when I go into it, I can see that there's a storage account, the SQL Server, and the databases. If I go into my SQL Server and click on the SQL databases, I can see that tf-test-db was created with basic. As part of my SQL DBs module, 3 databases were created, 1, 2, 3, and the third one was standard. The first 2 were basic. Right. This is what I wanted to do with my code, and that's exactly what was deployed. So that brings to the end of my session. I've covered all the 3 demos where I've shown how a single module works, how you work with multiple modules, and how you can use complex variables like a list and then loop through a specific resource block. All of this code that I've shown in the demo is available on the Terraform, on my GitHub repository, Terraform code, of course. And the other me, which is not the recorded me, is available live on this platform and can answer your questions in the chat window, which is on your left side. So put in your questions on the chat window, and let me answer those questions live for you. And if you have any further questions that I'll not be able to answer during this session, or if you have any other questions that crop up later on, whether it's related to Terraform or whether it's related to any other topic on SQL Server, Power BI, or for that matter on Azure Data Platform, anything related to Synapse Analytics or Azure Data Lake, Azure Data Factory, please do feel free to ping me on my Twitter handle at ManuSQLGeek. Thanks to the sponsors, and thanks everyone for attending this session. I'll be live with you on the chat window by answering the questions. Thank you everyone. Have a great day.